Thanks everyone for joining today, wherever you are. Good morning or good afternoon. Thanks for joining today's webinar on connecting and running Amazon Web Services ECS, Elastic Compute Service at scale with Consul Service Mesh. So with me today, I'm joined by Lachlan Ralph, Solutions Architect from AWS, who will go through some of the infrastructure services that they offer. And then myself, I will walk everyone through Consul Service Mesh, running on top of ECS and EKS as well. I predominantly focus on all things Consul. So with that, I'll hand over to Lachlan, who will do a little bit of intro and then kick it off with going through some of the AWS services. Thanks, cool. Lachlan, over to you.
Yeah, thanks, Tony. Hi, everyone. So as Tony mentioned, thanks for joining us today, wherever you are. I am Lachlan Ralph. So I am a Senior Partner Solutions Architect here at AWS. My focus around AWS is the enterprise scale customers, particularly the mining, energy, industrial customers. And I'm going to just give you a really high level overview of sort of the container platforms that we have here at AWS, sort of some of the drivers for them, some of the recommendations in terms of the types and the methods for deploying them, as well as some of the locations that we can deploy them and how you can manage them. So with that, we'll just jump into the next slide. Let's try this. Oh. All right, so here we go. As an AWS container overview, I think one of the first things that we should think about is sort of why are we seeing customers adopt containers today? Really, they drive an accelerated development framework and timeline, which is becoming more and more critical across IT organizations globally. They provide things like a uniform security and operational environment from dev, test, and prod, which really drives standardized security services and platforms, improves operational efficiency because you've got that standardized environment, and also because you've got the dev and test environments the same as prod, you're getting delivery speed because you don't have to go and worry about changes in the overall environment. And all of this leads to things like the increase in ability to provide testing, so like blue-green testing, and I think, Tony, we touch on some of that later, around how we can automate those test processes, again, so driving agility. So that's sort of the very high level why we're seeing containers being adopted. And with that, we'll just have a look at what does AWS offer in terms of the container landscape. So really at the high level here, you've got your compute types of containers. On the left there, you've got AWS Lambda, known well, loved well, lets you operate code without running any underlying infrastructure. You can execute code natively in Lambda functions. Secondly, we've got Amazon ECS, which is Elastic Container Services, and that's what we'll touch on today. Thirdly, we've got EKS. Not everybody uses the Docker engine under the hood to provide your container services and orchestration. Kubernetes, which is an open source platform that provides container orchestration as well as its own container engine, is being provided by AWS as a managed service in EKS. And then App Runner is finally there is really a way to accelerate the delivery of web scale apps. We won't touch much on that today. Along the infrastructure layer here, and this is really where you'd sort of think about your traditional VMs and bare metal servers, we've got EC2, which is the AWS way of deploying virtualization, and that underpins the container engines that we would traditionally see. We have also released a new service called Fargate, which really helps you step back again from having to worry about how to run your infrastructure. It takes away the requirement to run the virtual machine, the operating system, patch it, secure it, and provides you a scalable mechanism for running the infrastructure underneath it. Thirdly, the image registry here, ECR is Elastic Container Registry. This lets you store the Docker or the container images that you want to deploy. You can both deploy from them and also push changes to it. And then across the bottom, we've got all of the networking and integration functions that we provide out of the box to help you orchestrate, control, interact with, and secure your containers. So we're not going to touch too much on the integrations today. But that's just really a very, very high level of what the AWS landscape for containers look like. What we'll do now is we'll just jump into having a little bit of a closer look at what a pipeline with ECS might look like and the tools that you might go about using. So what we've got here is the pipeline from deploying the code all the way through to building and deploying the application, to orchestrating it, so integrating it with other surfaces, and then also observing the functionality of that application. On the left there, you've got familiar faces like GitLab. AWS offers a Git type service in code commit. In the build and deploy phase, we've got the HashiCorp Terraform platform, which we won't touch on today, but does offer the ability to orchestrate your build and deploy phase for containers, especially on ECS. AWS offers the ECR, the registry for your container images. Code deploy and code build is the services for actually pushing that code and building the services. And then CloudFormation is our standardized templating format for integrating with the infrastructure as a service that is the underlying AWS platform. Once you've actually deployed your application, you still need to be able to interact with it. You need to be able to do things like manage secrets that it may need for integrating with databases and other services, managing keys again for interacting with other services. App Mesh and Cloud Map help you monitor and access the network across the services. But what we'll be doing today is actually we'll be running through the Consul platform from HashiCorp, which provides that service mesh functionality over the top of our container platforms. And then finally, once we've got the application up and running, it's integrated with what it needs to be integrated with, we've actually got AWS native services again that let you monitor and observe what your application is doing. So CloudWatch is the core logging and monitoring platform that AWS runs. FluentBit actually provides you with the integration into the ECS platform to collect container metrics and monitors. Grafana and Prometheus as well are visualization engines. We also do partner with other visualization and monitoring providers such as New Relic and Splunk. So it's worth to note that there is a strong partner ecosystem underneath this as well. One of the things as well that I think that is important to touch on is that ECS, even though the control plane runs inside AWS, actually has a functionality called ECS Anywhere that lets you deploy the compute nodes on-prem. So what you're actually able to do is keep that ECS control plane in AWS, deploy a management engine inside your VMs or even on a bare metal server should you choose in your own data center. That then talks back to AWS and provides you with essentially extended resources. So if you've got services that are security sensitive that you can't move to AWS for any reason, you're always able to extend the ECS platform to your own data center as well. So with that, we'll just jump into EKS. So I think it's important to sort of understand that not everybody is coming to containers fresh. Some customers have got a history of using container services, and that may be running on-prem Kubernetes. So Kubernetes has been around since, I think, 2016, 2017, when it was open sourced. And there is quite an extensive uptake of those container orchestration platforms outside of AWS. So if you move or you want to come and build on AWS with EKS, I think a few key items here is that when you deploy EKS, you're actually running a vanilla upstream certified format of Kubernetes. We haven't done anything special to it in terms of modifying it or moving it to make sure that it works seamlessly on Amazon. And you've got confidence that when you run your services that would work on an on-prem instance of Kubernetes, it will also work inside EKS. The advantage here is that when you run EKS, we actually look after support, including backporting security fixes into that platform. Sorry. So that ensures that when you're running your your EKS platform on AWS, that you're actually ensured that you're getting the same experience that you would get on-prem, that your performance will be the same, and you get those benefits that we talked about before, where you can ensure your platform is consistent across dev, test, and prod when you're building applications, even if they're not necessarily running all on AWS. We do also plug in other services into EKS to make sure that you're getting the similar sort of experience when we talk about ECS. We integrate with similar levels of services that we saw in that previous slide when it comes to identity and access management, when it comes to KMS and container management. So you're getting the benefits of the AWS ecosystem being plugged into the Kubernetes system. One of the things that we do need to touch on, and this will also lead into the rest of the conversation around what Consul provides today, is the shared responsibility model for security that we have here at AWS. AWS is very clear about how we present the security relationship between what we provide and what we expect the customer to look after. We divide it into responsibility of security of the cloud, which is the AWS responsibility. And as you can see on this slide here, we've got things like regions, which are the AWS cloud as you know it. That's things like the availability zones. We look after the physical security and integrity of those sites. Same for the availability zones, which are essentially the data centers that make up regions. We make sure that the compute with our Nitro platform is secure and you're not getting compromised on your compute layer. We secure the storage. We do offer native encryption services for that storage platforms now for, I think, about 117 different services. Same for our database and networking. We look after the security for all of those platforms, making sure that they are secure and reliable for our customers to consume. What we do require, though, our customers to look after is things like networking and firewall and configurations. And that's one of the things we'll touch on today. Sorry, I have a frog in my throat. Things like operating systems, we do require our customers to patch. We will provide the AMI, which is the operating system image, but we require our customers to make sure that they are updating and maintaining those operating systems in a timely manner. At the top here, though, really it comes down to the customer data. And while we provide tooling to make it easier than ever to actually secure your data, the responsibility of security in the cloud with the customer remains with you. With that, I think, Tony, I will hand back to you to talk about Consul.
Thank you. All right. All right. So I'm gonna continue on now and talk about Consul, and specifically Consul and ECS. I do have a little bit of a demonstration towards the end where I run a multi-factor app that operates on both EKS and ECS, and they're part of the same service mesh where they can communicate service to service to each other. And I'll walk you through kind of that platform and that demonstration towards the end. But let's start off by examining what is service networking. Consul is a service networking solution, and we typically see service networking being comprised of 4 distinct pillars. Discover or discovery, which allows teams to the availability and health of all the services running in real time across all the environments, whether it's on AWS or on-premise. Secure, and that's to ensure that every service that is registered into Consul and operating as part of that service mesh is authorized to talk to each other and also encrypted as well. The other one is around automated automation, and that's to provide the immediate availability of services. So, for example, things can scale up and down without any operator intervention. And then access. How do we manage access in and out of that network? You can think of this as your north-south flows. Service mesh being your east-west flows typically. So Consul does provide this capability that enterprises need across these 4 pillars. And you kind of need this to kind of realize the complete service networking platform, right? From discovery, secure, automate, to access. So why would you consider Consul and ECS? ECS is becoming a popular container orchestrator because of its ease of use. It's focused around helping customers get started quickly, right? Now, typically we see customers mature, and as they mature in their ECS adoption, usually we see service mesh being considered as the next logical step for a number of reasons. Usually top of mind is always around security. So as the number of services kind of proliferate and dramatically grow, so does the volume of unencrypted communication, coupled together with the, inability to define rules about which services can communicate with each other. It creates a undesirable situation and an ideal situation for threats. So the ability to solve that security gap, I would say, is quite critical, right? Especially when we talk about zero trust. The other piece is the ability to properly gauge performance of applications. It's important when new services are constantly being brought online. How do you measure and trace an event, especially when you want to determine root cause of a problem, improve the mean time to resolve and so forth, ensuring things like high availability of services, also being able to control the flow of traffic. So things like AB, blue, green, how do I shift traffic from one version to another version without any interruption? Without kind of a service mesh platform in place, it's difficult to manage and control that traffic, which could lead to network issues and downtimes. Now, most customers also have workloads distributed between AWS and on-premise environments. So being able to connect these easily is something that customers are looking for. It's becoming incredibly difficult, and it requires often, resources, or significant amount of resources to create a solution that works in this manner. So they're typically your reasons as customers mature. But let's kind of shift gears a little bit now and let's look at a standard ECS cluster. And in this example here, we can see 2 microservices applications. Let's imagine, one of them being our front end and the other being our API, or, I'm going to call it a profile service. So let's walk through kind of this request path, a simple kind of flow. As a user accessing their profile through a website, what typically happens is that website is loaded by, a load balancer. In this case, we have an ALB sitting directly outside the cluster. And once it's taken you to that task running the front end, it then still needs to load the profile. And to do that, it needs to make an API call to the other service, right? Which is our backend service or, profile service. And that is usually routed through another internal load balancer, because you potentially have multiple tasks here for availability and so forth. So this typically represents the standard way of running things in ECS, but let's kind of see how incorporating Consul with service mesh augments this, right? So with this, we have Consul running on HCP or HashiCorp Cloud Platform, and that is running as a managed service. And then we can call that our control plane. Customers can also choose to run Consul as a self-managed offering as well. on each microservice application, there is an Envoy sidecar. So the sidecar acts as a proxy to help handle a lot of that service mesh goodness, that communication between services. It's also responsible for encrypting and decrypting the traffic, right? Ensuring there's MTLS, authorizing the connection so that, our front end can talk to our back end and so forth, right? Additionally, there's, when we deploy Consul for ECS, there's an ACL controller. And the ACL controller is responsible for issuing tokens. It's also responsible for monitoring the ECS cluster so that it can register services or tasks into Consul as they come online or offline, right? So also notice one thing here is if we look at the task here, there's no more internal load balancer when we bring Consul. That's because Consul manages the load balancing natively for us between services. So the Envoy proxies will always attempt to route services and communicate with a healthy service. And if that service, for example, our profile service, my API service becomes offline, then it'll be rerouted to another healthy available service if one exists. So there's a lot of benefits, and just to kind of summarize some of the things I spoke about, but usually the three major benefits that we see customers adopt Consul and ECS is zero trust networking, like spoke about. Requests between tasks are fully encrypted with MTLS, so this prevents any potential attacker or anyone on the network to sniff things in plain text traffic. Requests will always flow through those sidecars. And then Consul can also block unauthorized services. So I'll walk you through a little bit and show you how we define fine-grained authorization, and we call it our intention policy. So in the example I showed earlier, you would have to explicitly define that the front end can talk to the profile API service. The other one I spoke about is high application availability. So Consul can be used to configure the behavior of proxies for things like retrying failed requests, timeout after a certain period, circuit breaking services that aren't responding. So these controls can increase the reliability of microservices without requiring additional changes to underlying services or applications. So as an example, we often see services built, but often once they reach a certain load, you don't want the service to completely crash and not respond. Typically that's bad experience. So we can do things like retries on behalf, or we can break that service and do a redirect to something else so that the experience is much better. Also, the kind of summarizing the last point, any platform, any runtime, this is typically how Consul operates. We're able to enable the routing of different services residing in different clouds and different runtimes so that we can connect our workloads. Typically, we see this from on-prem to cloud like AWS. And in my example, in my demonstration later, it's actually enabling this capability from EKS to ECS. So I just want to talk about TLS and MTLS for it. This is a big topic today. Everyone is focused around security, every organization, every enterprise. There's a lot of focus around this. So zero trust is an important flavor. And just to talk about this a little bit, every service that's operating as part of a Consul service mesh, whether it's talking across VMs like EC2, an on-premise VM, a service in EKS or service in ECS, when it's registered, Consul will issue a TLS certificate. It's a short-lived TLS certificate by default, and that's 72 hours or 3 days to represent and for the identity of that service. And then Consul will automatically rotate that certificate as well. But we use that certificate to establish MTLS between services as well. So, it's kind of good to have this capability to continuously rotate and manage that certificate rotation for services. It removes that kind of overhead from application teams, so forth. So with that, I'm going to kind of walk through a demo of what I've kind of built here. So there's two parts of this demo. I'm just going to talk through my current initial state, and that is, so I have an AWS cloud. I deployed this one in AP South East 2, which is Sydney. I have an EKS cluster running my application, which is HashiCorp, and HashiCorp has a number of components to it. The front-end components like Nginx, the front-end service, and the public API service is built on my EKS cluster. And then I have a lot of my back-end services on ECS. So things like the product API, the payments, and the database, which is the product DB is actually a Postgres database. Payments, there's actually a Redis. So there's actually a few moving components to this. And I'm using Consul on HCP as well for this. So if we look at this, what I'm going to actually do is I'm going to show you the actual web interface. So I do have it in Ingress. I have an API gateway on my EKS environment, on my EKS cluster, and that's exposed publicly. And I'm going to show you first the kind of front end. And you'll see the front end a little bit broken because I haven't enabled service mesh or any of the services on ECS to register with Consul yet and inject the sidecar. So you'll see a broken app, and that's completely normal. But all I'll do is I'll run some Terraform. It'll take hopefully, 30 seconds or so, and then we'll see the services register into Consul, and then you'll see the service online. But when you do see that, all the services are communicating with MTLS. You'll see an intention policy that I'll walk you through that defines how the services can or how the services are authorized to talk to each other, and that fine-grained control as well. But keep in mind, we can apply all the other service mesh goodness on top of that, things like traffic management. So you can do your blue-green AB, but then you can do things like retry, circuit breaking, like I spoke about earlier. But then also with service mesh that I haven't touched on is you can do things like get a lot of rich observability from the sidecar, a lot of telemetry as well, and tracing capabilities as well. All right, so with that, I'm just going to switch screens and kind of walk you through this. All right, so hopefully everyone can see my screen. Just give it a few seconds to make sure there's no delay. But what you should see, or what I'm sharing at the moment, is my ECS cluster. And I have one cluster at the moment with 3 services. Like I mentioned, these are my backend service, my product DB, my product API, and my payment service. If I go to EKS, you better see that I have my EKS cluster, and you can see I have a whole bunch of services deployed on this as well. All right, we won't spend too much time on the EKS side of things, but I do have some Consul services deployed on here. I can show you the pods later with the front-end services. That's okay. But let's quickly jump and have a look at what's on Consul. So this is the Consul UI. You can kind of operate Consul through the UI, through the API, through the CLI with Terraform and so forth. Again, you can see my front-end services. I have an API gateway that I spoke about earlier. I have my front-end, my Nginx, my public API, and they're in mesh. You can see they're in mesh with a proxy. The public API isn't talking to any other service at the moment. If I look at my topology view, again, it's only aware of the front-end services. I do have some intention policies already predefined. So these are like, hey, my API gateway can talk to my Nginx service. My public API can talk to my payment service. So these are the fine-grained controls that we define to allow services to talk to each other. This is my half-built HashiCorp app, and you can see there that, I can't see anything at the moment. There's no coffees. There's nothing in terms of, the products here at the moment. What I am going to do now is quickly bring this down. and I'll bring it up in a little bit. I have a little bit of Terraform code here. So this is actually built using the Learn Consul ECS tutorial. So we'll have a link that we can share a little bit later that if anyone wants to try this, they can walk through the tutorial. It's the same Terraform code that will stand up the environment. It'll stand up the AWS environment that I described. It'll stand up HashiCorp. So stand up Consul and HTTP. It's all self kind of packaged, so you can kind of do this and have a go and see how it works yourself. But I'm just going to have a look here. I've done a Terraform plan already. I'm just going to do a Terraform apply now. And we're just going to have a look at the backend services. So why it actually kind of does that plan quickly, sort of again, go back to ECS and quickly take notes of, if I go into any of these services here, and look at the tasks, you can only see one container running, which is the application container, right? Product DB, that applies for every other service as well. So what we will see in a little bit is the sidecars come up. Sorry, wrong service. We'll just go back to that one, focus on this one a little bit. So let's do this, and let me just apply that change. What I will do is we shift that over here. All right. We'll go back to my service view. It will just take a little bit of time, hopefully not too long. If there's any questions, feel free to put in Q&A or in the chat. I'm happy to kind of answer them. I mean, this doesn't take too much longer. You can see in this piece here, what's happening in my Terraform code is I'm deploying the ACL controller. But then if you look at my services for payments, you can see here there's some console inputs as well. All right, so that deployment or that change is done now. Just give it a little bit of time and it should come to. So let me go back and look at my ECS tasks. Okay, so we see the ACL controller is online now. Let's just go back into one of the services. Okay, it's still coming online a little bit. You can see it's still in progress, so we just got to give it a little bit more time to do what it needs to do. But you can see it's slowly coming up. This is the payment service. You can see that's the application service, and you can see this is the sidecar proxy, which is Envoy. You can see here that's the Envoy URI image there. And then we have a few other services that come up together with that that kind of help handle the health and also or looking after the health sync of the service. Consul is always wanting to be aware of the health of the service so that if the service is unhealthy, it won't route to it. And again, going back, it will route to the next available instance, right? We have the mesh init service, which is going to help register the service with Consul. So they're coming up. It was a little bit quicker before, but we just give it some time. And then we should see the services come online as well. Still going. All right. We can come back to this in a little bit. Essentially what happens in a little bit, once all the deployments happen, you'll see the services come online here, and then we have a complete app, which I wanted to show you. So the live demo isn't working as I expected just yet, but I'm confident it will happen in a little bit. All right, in the meantime, I know there's some questions here. So I'm going to answer some of these live. Is the ACL controller required to deploy in both EKS and ECS in this scenario? No, so the ECS controller is, the ACL controller is specific to the ECS kind of architecture. In EKS, we don't have that kind of same sort of controller that sits there. So there are other services that kind of manage that for us in EKS. All right. This is not happening for me today, right? All right. All right. So what I might do is I might wrap it up. I've been deploying this continuously today, off and on. I will stay on to see if there's any other questions. Whilst I see if I can get this kind of kickstarted again, and the application running. But thank you, everyone, for joining. Happy to hang on for a little bit. And if it does come up and finish coming online, then I will show this and bring this up for everybody. One more quick thing here, switching screens a little bit. So there is an overview page. You can visit our GitHub repo. This was the same tutorial, same environment that I spun up. If you kind of go to our tutorials page, you can run the same type of environment like I mentioned. It's a step-by-step guide to set up an environment. Terraform code's all there to deploy everything you need. So you can kind of walk through it and break it yourself like I did. With that, thank you.
Thank you, Tony. Great presentation. We obviously didn't make the right sacrifices for the demo gods this morning. So
no, they worked before, but it always happens live. But I am I'm destroying it and recreating it. So that's a great thing here. I can do that pretty quickly and see if we get it to just do its thing again.
Yeah, absolutely.
So if it, I'll hang on to see that. So I mean that we're kind of officially ended the session here in terms of the webinar, but if anyone wants to hang on, I'm just going to kind of share my screen again and see if we can get this working. It will take a while. I've just destroyed the entire environment actually, which is kind of what I realized. So it's going to take a while to destroy the EKS nodes, the ECS nodes, the VPC, because it's going to do that from scratch. So it could take 10 or 15 minutes. So maybe we'll park it. And I encourage you, if you do want to try it, go to the tutorial. And I'll just show you what this tutorial and where that is. It's this one here. And if you actually go through the scenario, you actually deploy the environment like I intended. This is kind of where I was up to. I was running the Terraform apply. I was doing this a lot earlier to make sure it was working, and then it didn't want to work on me in the final time. But what you end up with is kind of the page up, but keep in mind that all the services will be communicating across ECS, and it's similar. You can have services spread across on-prem as well, and they'll be communicating service to service using Consul service mesh. It was a bit odd because it was a bit stuck around launching the. It actually didn't get as far as launching, relaunching, or redeploying the services at all. So interested to know why that happened, but we can always revisit that. Thanks, everyone. I think we're going to wrap it up here.
Thank you, Tony.
Awesome. Feel free to kind of drop off, everybody.
Thanks all.